All right, so we are about halfway done with our first half of our discussion of complex numbers, and that's just simply how to work with complex numbers. We've talked about how to work with purely imaginary numbers so far. How do you simplify something that's a square root of a negative number? How do you do arithmetic with purely imaginary numbers, and specifically multiplying and exponents with imaginary numbers? So now what we're going to do is we're going to move into the full complex number. So if it has both a real part and an imaginary part, both, now what do you do with those things? And so that's what this video will focus on, and the next video. So let's get started by taking a look at the learning objectives for this video. So you can see everything here involves evaluating an expression that involves a complex number. So again, when we talk about complex numbers right now, specifically, we're talking about something that's fully complex. It has a real part and it has an imaginary part, both. We already know how to do all of these things with numbers that are real only. And we know how to do all of these things with numbers that are imaginary only. So what we're going to focus on in this video are numbers that have both pieces, real and imaginary. Now, when you think about evaluating, and remember, evaluate, that just means find the mathematical answer, right? So if I said 2 plus 5 and asked you to evaluate the expression 2 plus 5, you would tell me the answer is 7. Okay, that's all evaluate means. And so we're going to do that with complex numbers. But notice of the typical operations that we learned back in elementary school or the beginning of middle school, division is missing, right? We don't have division here. So division is somewhat complex when it comes to complex numbers. So that's going to get its own video. That's going to be the next video. In this video, we're just going to focus on these, okay? Also, in this video, we're only going to do one example and outline the procedure for each of these. So we're not going to have lots of examples here. Outline the procedure and do one example of each of these. Addition and subtraction are pretty straightforward. Multiplication and exponents, I'll have some additional videos with examples only for those. So if you need more examples, you can watch the other videos. All right, so there's our learning objectives. There's the big idea. Let's get started by talking about addition. Actually, even before we get started with addition, just a quick reminder of the anatomy of a complex number. The anatomy of a complex number, okay? So a complex number is going to have a real part, so maybe 5, and it's going to have an imaginary part, like maybe 3i, and then those two things will be combined by either a plus sign or a minus sign, okay? So something like this, it has a real part, and it has an imaginary part. That's what we're going to be working with. And you'll remember from our last video when we talked about working with imaginary numbers, specifically multiplying them and things like that, we talked about that I can be treated like it's any variable. And that's going to be the key to this whole process. So I'm going to say just an in general. This is an in general statement that's going to apply to all of our different operations that we're going to look at here today. In general, treat a complex number like a binomial. So remember when we studied polynomials, binomials are things that just have two terms. Okay, so this thing right here is just like, it's kind of like, it's sort of like, it's like, oops, like usually starts with an L. It's like this thing right here, right? Do we see the similarities between them? Standard form reverses the order, but outside of that, they're basically the same. So we're going to treat this complex number just like it's an imaginary number with one exception. Since we know that I is equal to the square root of -1, or perhaps more importantly, we know that I squared equals -1, anytime I has an exponent, we're going to simplify that just like we did in the last video. So simplify i's with exponents. That's really the only thing that's different. I's with exponent, that's an I apostrophe S is what that says. Sorry for my bad handwriting. I's with exponents, That we're going to simplify. Everything else we're going to treat just like this, okay? So when you think about all the things we learned how to do with polynomials, it's going to be all the same stuff, except with a polynomial, having this was okay. With a complex number, having this is not okay. We're going to turn that into a -1. Okay? That's really the only difference. That's really the main difference right there. That's it. Other than that, everything we know about polynomials is exactly what we'll do. So let's get started by talking about addition. Addition. Addition with polynomials was simply a process of combining like terms. And when you combine like terms, you don't change their exponents, which means addition with complex numbers is simply going to be combining like terms. That's all it's going to be. We're not going to bump into any problems with exponents. So that means we're not going to have to simplify i's. We just simply are going to combine like terms. That's all that we'll do. So here's an example. Example number 1. Let's take the complex number 3 minus 4i. That's already written in standard form, so life is good. And let's add it to the complex number -2 plus 7i. Okay, so there we go. Two complex numbers, and we're going to add them together. And the way that we will add them is by combining like terms. So right here and right here, these things are like terms. They're like terms because they don't have a variable. Okay, or maybe a different way that you might think of this, instead of combining like terms, is we might say combine the parts. Combine the parts, because remember, these are both real parts, right? They have a real part and they have an imaginary part. So the real parts are always going to be like terms. So we combine those together. So I'm going to have a 3 plus a -2, and that's going to be my first piece right here. Okay, then I'm going to combine together the imaginary parts. So the imaginary parts. The imaginary parts are also like terms because they both have an I. So that makes them like terms. Remember, the sign goes with the part. So -4i, that's one part. And I'm adding it to a 7i. That's the other imaginary part. So these are getting added together. Right? When I add together the real parts, 3 plus -2 equals 1. When I add together the imaginary parts, -4i plus 7i equals a positive 3i, and so that becomes my answer, 1 plus 3i. That's my answer. Okay, so addition is relatively straightforward. If you want to think of it using the vocabulary we learned with polynomials, literally you're combining like terms. If you want to use the vocabulary associated with complex number, we're combining the like parts. It doesn't matter which vocabulary you use, it's the same effect. Add together the things that don't have i's, add together the things that do have i's, and then that's going to give you your answer. So that's addition. Subtraction. For subtraction, you'll remember what we did with polynomials was we distributed the negative sign. We turned the negative into plus or minus. Okay, we said plus -1 times stuff is what we did. Then we distributed the -1. And then we added. Okay, so that was the process we used with polynomials. And it's going to be the exact same process with the imaginary numbers. So let's take those exact same two imaginary numbers, 3 minus 4i and -2 plus 7i. And this time, instead of adding them, let's subtract them. So it's literally the exact same thing we did when we learned how to do polynomials, 3 minus 4i, and we're going to turn this minus into plus a -1 times -2 plus 7i, right? Because we've learned that subtraction is the same as adding a negative. And we also know that specifically having a minus sign in front is like a sneaky ninja -1. So we just make both of those changes at once. And now what I can do is I can distribute that -1. 1. So when I distribute that, I get 3 minus 4i plus -1 times -2 is +2. And -1 times -7i, I'm sorry, times +7i becomes a -7i. There we go. So I just distribute that. And now I add. In other words, I combine like terms, right? When we say add, what we really mean is combine like terms. That's what adding is. Or if you want to think of it with the imaginary numbers idea, it's combining like parts, okay? But whatever way you think of it. I've got a 3, and I'm going to combine the 3 with a 2. So 3 plus 2 is equal to 5. And I have a -4i and a -7i. Combining -4 plus -7 is going to give me a -11i. And so there's my answer. 5 minus 11i. There's my answer. So that's the process of subtracting. All right, moving on to multiplication. And remember, if you need to take a break as we do this, go ahead and pause the video, take a quick break, and come back as we start talking about multiplication. Okay, multiplication, just like it was with polynomials, is a process of distribution. Okay, process of distribution. So if there's only one thing in front of your complex number, so let's suppose I've got a 3 times 2 plus 7i, or maybe I have a 5i times 1 minus 4i, okay? In both of those situations, so I guess this is example number 3, and this is example number 4. In both of those cases, it's relatively straightforward distribution. I'm only distributing one thing. Okay, back when we learned about polynomials, we just called that a single distribute. So 3 times 2, that would give me a 6 for my real part. And 3 times 7, that would give me a 21. And then I for my imaginary part. So no big deal there. Same basic idea with this. I'm going to distribute the 5i. But notice when I distribute this, because it has an I, I'm going to have to work with exponents. So 5i times 1 is 5i, no big deal. 5i times -4i, this is what we did in our last video. First, I'm going to multiply the number pieces. So 5 times -4, that's going to give me a -20. And then when I multiply the variable parts, I'm going to combine their exponents. So I to the first power times I to the first power becomes I to the second power. Now, this is where we said, okay, I squareds, we're not allowed to leave those with exponents. We know what I squared equals. I squared equals -1. So I'm going to take that I squared and turn it into times -1. So what I end up with then is a -20 times a -1. That becomes a +20. And then the last thing I would do is reorder it so that it's in standard form. Okay. Now that looks like a lot of work and a long process, but realize a lot of this we can do all in one step, right? I would probably, if I was doing this myself, I would probably do this step and actually write that out on my paper so I make sure I keep track of stuff. These two steps I might combine together, or these two steps I might combine together. I would say as a brand new complex number algebra student, I would do that in those 3 steps. These are the 3 steps I would probably write on my paper. Remember, the basic adage is the more work you show, the more right answers you get. So until you get familiar and comfortable with imaginary numbers, I would encourage you to at least do these 3 steps on your paper. But to a certain extent, that's up to you. Okay, so that's multiplication when there's only a monomial on the outside. We've also learned how to multiply when there's a binomial on the outside. So let's go back to those same 2 complex numbers that we were working with a minute ago, and let's multiply them together. So on example number 1 and example number 2, we took those 2 complex numbers and we added them and then we subtracted them. Now we're going to multiply them. And remember, multiplication is still a process of distribution. It's just now we're going to have to distribute twice. So this is what we called double distribution. So the way that and for those of you who learned FOIL and like FOIL, FOIL will still work with this also. So feel free to use FOIL. But the method that I prefer to teach is double distribution. So I'm going to take that whole thing as a single unit, and I'm going to distribute that whole thing to the two pieces, okay? When I distribute it to the -2, I'm going to end up with that whole thing times a -2, okay? And remember, I always think of this as a plus sign in the middle. So if this was a minus sign, I would have made it plus a -7. That lets me always put a plus sign in the middle here. It makes my life easier. And then I'm going to distribute this whole thing to the 7i. So I'm going to have that whole thing distributed to the 7i. So that's where I would start. And now for the second distribution, because we call this double distribution, now I distribute those things into the parentheses here. So from the first one, I'm going to get a -2 times a +3. -2 times +3 is a -6. And then from the next one, -2 times -4 is going to give me a +8i. So that takes care of the first piece. I still have this plus sign that hasn't gone away. And now I'm going to distribute this next piece. So a 7i times a 3, 7 times 3 is a 21i. And then a 7 times -4, that's -28. And then I times I would be I squared. Okay, so I know there's two things I need to do. I need to combine like terms, because I definitely have like terms. And I need to get rid of the I squared, because in the land of complex numbers, I squareds are not simplified. We know they equal -1. Aunt Sally tells me that I should usually do exponents first and then do additions later. And so I'm going to obey Aunt Sally on this. I'm going to start by taking care of that I squared and turning it into a -1. That's going to give me a -28 times a -1. So those are going to combine together to give me a +28. Now, all the rest of this stuff I haven't messed around with yet. All that stuff is still there. It hasn't gone away, so don't lose it. I'm just only working with this last term right now. So after I take care of that I squared, what I end up with is this thing that has 4 terms. And it has 2 parts that are real. So in my real part, there's a -6 and there's a +28. So I'm going to combine those together. -6 plus 28 equals 22, +22. And it also has an imaginary part that needs to be combined. So 8 plus 21 is going to give me 29 i's. And so that becomes my answer. So this is the process of multiplication. A little bit more involved because there's different scenarios that can happen. But notice that in all 3 scenarios, our governing principles are the exact same principles that we used when we learned about polynomials. The principle in this case of distribution. The only thing that changes is anytime I run into a situation with exponents, I'm going to change those exponents into a -1. Or I squareds turn into a -1. If it wasn't squared, if it was something else, obviously, then it would turn into something else, as we learned from our last video. All right, final topic. And I know this video is getting a little bit long, so I'm going to try and make this one brief. Exponentiation. And again, if you need to take a break before we get into this, pause the video, take a quick break, and then come back and let's talk about exponentiation. All right, so the basic process that we learned when we did exponentiation with polynomials is going to be the same. And what we did was we turned it into multiplication. Okay, so remember there was this issue with exponents and polynomials that exponents cannot distribute on a polynomial. All right, so if we take, again, let's just stick with one of the complex numbers that we've been working with. So I'll take 3 minus 4i. Okay, we've been using that through this whole video. If we're going to square that, We've learned over and over and over again that squares cannot distribute across plus and minus signs. That's not something I can do. So when we did this with polynomials, what we had to do was we had to start by using the definition of a square, which means this thing times itself. And we changed it from an exponent problem into a multiply problem. That's what we did with polynomials, and that's exactly what we're going to do with complex numbers. And now from here, it's exactly the same as example number 5. So we're on example number 6 here. It's exactly the same as example number 5. I'm going to do this with a double distribution process. I'm going to distribute the first thing to the second thing. The second thing has 2 parts to it. There's a real part and there's an imaginary part. And so I'm going to distribute to both of those. When I distribute to the real part, I'm going to get that first thing times 3. Now, this is where I talked about, I always treat minus signs as plus and negative. So I'm going to turn this into plus -4. That lets me put a plus sign right here in the middle. And now I can distribute that first thing, 3 minus 4i, times just the imaginary part, which I'm going to call a -4i. And so that's the way that we learned to do that back when we were doing polynomials, right? So now we can distribute again. This is the second, our double distribute. I'm going to distribute those things again. In the first one, I'm going to get a 3 times 3. That's going to be 9. And a 3 times -4 is going to be -12i. And the second piece, a -4 times a +3 is a -12i. And then -4 times -4 is going to be +16. I times I is going to be I squared. Okay, so that becomes my all 4 terms after I do my double distribute. Again, like Aunt Sally says, we're going to take care of this squared piece first. So this is going to become a 16 times -1, which is equal to a -16. All the rest of this stuff is still the same. We haven't fooled around with anything else yet. And so now I have combined, or I'm sorry, now I've taken care of all my exponents. I'm ready to combine like terms. So I have a real part of 9 and a real part of -16. When I combine those real parts together, I'm going to get a -7. And I have an imaginary part of -12 and another imaginary part of -12. When I combine those together, I'm going to get -24i. And so that becomes my final answer. Okay, so this is the basic process for exponents. We turn it into a multiplication, and then we use our distribution process that we learned for multiplication. That was the process for multiplying, just everything was distribute, 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 but then deal with those I squareds as they come up, okay? And we learned how to do that in our last video. Addition and subtraction really was just simply a process of combining like terms. The only thing to watch out for was for subtraction problems. Before you combined like terms, you would turn the minus into a -1 and then distribute it. So that takes care of all of our learning objectives for this particular video. We've done all of these things except order of operations. And the only thing that happens with order of operations, well, they're exactly the same as they were when we did regular numbers. So we're going to start with grouping symbols first, right? That's the P, and please excuse my dear Aunt Sally, or PEMDAS, that's the P and DENDAS. We're doing grouping symbols first, then we're doing exponents second, multiplies and divides come third, adds and subtracts come last. So those are our 4 steps for order of operations, and they're the exact same problem. So as we saw in these different examples, if you have a scenario where there's adds and subtracts and there's exponents, you're going to deal with the exponents first and then deal with the adds and subtracts last. All right, so this is the basic idea. Thanks for watching. If you want more examples with multiplication or with exponents, there will be a couple more examples in other videos. So just find those videos and watch those. But that takes care of the basic overall idea. Thanks for watching. Have a good one.